Hello, everyone. Pleasure to see you all connected to our today's session. And today we will be talking about use of 3D Experience platform for all of you who are Solidworks users, I believe. There are two parts of our presentation today. In the first part, it will be a presentation from my colleague, Alessandro Tornincasa from Italy, on 3D Experience called about the 3D Experience platform. And in the second part, it will be me, Alexander Babkevich, who is an industry process consultant for electromagnetics software. I will give you a brief introduction into capabilities of Simulia with SolidWorks and on the platform in general. So let's get started, and I have a big pleasure of passing the microphone to Alessandra, who will talk about the 3D Experience platform. Please, Alessandra.
Thank you so much, Alex. So my name is Alessandro Tornincasa. I work as an industry process consultant in the Dassault systems. So today I want to start with the history of Dassault systems. So Dassault system is well known because it's been the catalyst and the enabler of the world's greatest industrial transformations. I will switch to the next slide, where I will show you the different phases of this transformation. So the first phase is called digital mockup. It started when Dassault Systems was founded. Actually, it's a branch of Dassault Aviation that use a software to do the 3D design. And in 1981, we started to release a software that is known as CATIA to do the representation of the mechanics in 3D, and so we started with Dassault Aviation, and then it became a software that was commercially available. The second stage is called digital mockup. It's important because it allowed to represent very complex systems. In fact, with CATIA in 1999, Boeing was able to model the Boeing 777. So we are talking about a virtual model that includes the structure of the plane, but also the cabling up to every single screw. So very, very complex model. Then the third stage was PLM. Actually, it's Dassault Systems that invented the word PLM, so what we call the life cycle, so the end-to-end product management in 3D from the design through the recycling. And actually, the customer that requested this capability and that helped guided us in developing PLM was Toyota with their lean management principles. The fourth stage is called the 3D Experience platform, which we will see in a minute. We allow to collaborate and develop on a unified platform for every part of the company, not only the technical people and the engineers. We involve everybody, and this allows to create virtual environment. In fact, the 3D Experience platform was used to model a virtual model of the city of Singapore. And then we go on. Our next ambition is to create the virtual twin of the human body, because we have the technology. Actually, we have already built the simulate a model that can simulate the functioning of the heart, and also we are progressing in developing technologies for AI. Actually, you know about SolidWorks, but SolidWorks is only one of the brands. So we have the Dassault System has acquired lots of technologies over the years. In fact, SolidWorks was acquired in 1997. It's just one of the brands of the Dassault System. So we have SolidWorks, we have CATIA, then we have Simulia for the simulation technology. Delmia for the manufacturing, and 3DExcite for rendering. So we have lots of technologies. We have 12 brands, and they allow to do 3D modeling, simulation, do information intelligence, and collaboration. And we serve 11 industries. We have tailored solutions for every industry. Maybe today I will show you something about aerospace and defense, because I know that in this moment there is a lot of development in Ukraine in this field. And indeed, we have lots of customers in this area. If we quote the two most famous, we have Airbus and Boeing. In aerospace, we have Thales, Safran. So you will see lots of famous names that are served by Dassault Systèmes software. So what is the 3D Experience platform? So we have so much technology and with so different solutions that in 2012, we decided to unify all these technologies in a unique platform, because each of those applications was working in silo. So each of with a proprietary file format, there was a lot of export and import. So we decided to create a unique platform where you could leverage all of this technology, but also applications that are not necessarily tied to engineering, also applications that can be tied to business management. For example, you want to build a plant and you want to see how much time you have to wait until you need to replace a part, how much energy is being consumed. Thanks to our technology, you can really simulate everything. In other words, if you want to explain in a different way, it's a platform that allows to capture all the processes of a company, and it connects any team. So anybody can be from purchasing, from manufacturing, from finance, can participate in the product development process, because we have applications on the platform that are dedicated to each of those people. The platform is a cloud platform, and it's different from other platforms because we provide a complete solution. So we provide what is called the infrastructure as a service. So it means that we have our own company that is called Outscale, that provides the data centers, the physical computer resources, the network infrastructure, the operating system, the database, the storage, and we also take care of security, backup, disaster recovery. So this is a great service because, it's very expensive for a company not only to buy hardware, but also to secure your data. And then we provide also what is called the platform as a service. So basically the platform, when we operate it, we do the monitoring operations, the maintenance and upgrade. So it means that if there is a new version of our software, we upgrade the software on the server side. So you don't have to do anything. We take care of all of that. And then there is the last portion, which is called software as a service. This is the layer that is visible to customers. So basically, they simply open a web page, they access the platform, and they can see the software that is available to them. So for example, if I want to use an application to model on a browser, I can open that application and start working. So all the rest is taken care by Dassault Systèmes. And this is a great value because you reduce the cost of maintaining the hardware and integrating all the solutions, because we have a solution that is already integrated by design. Probably maybe some of you will be asking, how much is your solution secured? Where is my data? Can there be some dangers by hackers, we have a page that is called 3D Experience Trust Center. You can access it by typing www.3ds.com/trust, where we have several white papers that explain you our policies for what concerns the security, the architecture of the platform. But I can grant you that our security level is higher than the security for banks. If you want to see some information about our data center, currently we put our data centers based on the demand for using these cloud solutions. So for example, for Europe, we have our data center in Paris. For America, we have a couple of data centers on the two sides of USA, and then we have different data centers in Asia. Actually, we go by demand. For example, in Italy, the public sector has been asking for a data center in Italy, and we have a good amount of customers now. Soon, we will have a data center also in Italy. For what concerns the University of Kiev, I want to show you a solution that we have developed as Solidworks for students that you already have, and which can be the start for you for using the platform. The solution that we have consists in browser-based design tools, because today, one issue is the IT overhead, because when you buy hardware or software, there are many pieces of software, and you need to put in place an IT infrastructure that needs to be maintained, updated, and also protected by, for example, hackers. And you need to invest a lot of money. It's very complicated. So you need to invest in servers and so on. Another issue is mobility, because today what we see is that young people like you students are setting the trends for the next 10 or 20 years. So today, many professional apps can work from Chromebook, tablets, smartphones, like Google Drive or Google Sheets. So you can do a lot of things without installing software. So today, our students are expecting to do the same stuff also with mobile devices. So they want to use computer-aided devices from a browser, and we can provide with the platform software that allows you to work from a browser. The other issue is data management. Just to make an example, less and less young people are familiar with the concept of files and folders, because today they are working with mobile devices. And so what they know is what is an app, and they know that when they open an app, they can search, find some data, and then open it. So they will expect to have the same experience that is similar to using Google search when they are interacting with the CAD. Another aspect is the collaboration. New tools are replacing emails, like direct messaging when you communicate internally, like WhatsApp, for example, professional social networks like LinkedIn, where you interact with customers and partners, or virtual meetings to communicate with everyone anywhere. And finally, there is a last trend. So our customers want more power. So the designers want to have more and more powerful tool to tackle complex designs with technology like artificial intelligence, cloud computing, and generative design. And we have all those technologies on the platform. So just to repeat, the response to all these challenges by the Dassault Systèmes is called the 3D Experience Platform. So it's a cloud-based environment that works from your browser, that connects all the people involved in the design. So it connects the people, their ideas, their data, and also the software solutions. So there is a a large number of tools for every member of a design team and for every stage of a product development process. For example, you can do product management, you can do life cycle management, you can do advanced simulation, machining, robot simulation, factory layout, modeling, and much more. So it's a cloud solution. So it means it's very fast to deploy, and the updates are automatic because there is no need to do IT management. And at the same time, we respect the highest security standards. You can access it anytime from any device, so even from a tablet or a phone. And it's scalable because we have, let's say, solutions that can grow with the companies. And we cover many, many disciplines. So talking about the browser-based design, which is what University of Kiev has, the advantage is that it works from any operating system. So you can use it from iOS, from Android, from a personal computer. And as I said, there is no need to install anything. So as soon as you receive a link to access the platform, you simply open your browser and you can start working. And also, this is valid for the updates. If there is an update of a platform and the updates are happening every 2 months. So every 2 months, you have new capabilities. Let's say that on next Sunday, there is the upgrade. On the following Monday, you simply access the platform and you can enjoy these new capabilities. You don't need to uninstall and reinstall the new version of the software. And this is a big value, especially for universities, because upgrading computers and software is it takes a lot of time. These apps also have natively the touch support. So if you have a tablet, you can really model from your tablet. You can model parts, assemblies. So it means really that you can design from any device. You need to have an expensive computer. So if you have a tablet or a Chromebook, which is usually cheaper, you can work with these applications. Or if you love Apple computers, so you have a Mac, you can work on Mac. There is no problem. Another important concept is that there is automated data management. I will try to explain it from the standpoint of university students. Usually universities don't teach data management or PLM because it's very complex to put in place the infrastructure. You need to have a server, you need to configure a lot of things, so nobody does it. But the platform has data management that is already embedded in the system and it's automated. So you have the ability to create revisions. You can, for example, check in and check out files. You can collaborate on the same design and do real data management without needing to have a server because it's included and it's, let's say, part of the process in a natural way. Then we have interesting technology, for example, the design guidance, which means it's a technology in our CAD on the browser that allows to define the material of the part. You can define the areas to avoid, the constraints, the forces, and the system will automatically figure out what is the best shape for your model. So we call it design guidance, but if you want, you can call it a generative design. And then we have, well, I used to call them computer-aided design technologies, but today we can call them AI. In these solutions, there are a lot of AI capabilities. For example, in this capability, you have the ability to ask the software to replicate the component with the mates in similar positions in an automatic way. So artificial intelligence will figure out the positions, but there are many, many more examples of artificial intelligence capabilities that are available in this software. So how does it work from a licensing point of view? I'm telling this for who is the administrator of the platform. So the platform has applications, but from a licensing point of view, they are divided in functional roles. So it means that if I have to do parametric modeling, I need to be assigned a role for parametric modeling. If I want to do only freeform, there is a role for that. If I want to do rendering, there is a role for that. The advantage is that you have more flexibility because you take only the license that you need in that specific moment. And there is a huge portfolio of applications today that the University of Kiev can use. For example, parametric design, freeform design, rendering, modeling of sheet metal, modeling of molds or welded structures. So a lot of capabilities. But actually, the platform can go further than that because this is just the surface. Once you save your data to the platform, other applications from other Dassault Systèmes technology can be used to do many things. And I will be showing you an example in the aerospace sector. We call them industry solution experiences. For example, if you have to model a drone, you have applications that allow to create configurations of your drone, or also do what we call model-based system engineering. So what is the global behavior of your drone? You can even plan the design from a functional and logical point of view. So you can really approach in a holistic way your design. This is the simulation that you can do from a structural point of view, electromagnetic point of view, or fluid dynamic point of view. And for example, you can study what is the best profile of the wing. And do concept comparison, as you can see here. You can do design by experiments, so compare different kinds of designs. Also, we have applications from other brands that allow to simulate the behavior of your vehicle in the context in which you will operate, because we also can incorporate the maps and simulate also the physical behavior of a drone. And of course, as I told you, this is just the surface. We have really applications for any kind of need because really the platform includes all the technology from Dassault Systèmes. This is the generative design. So you create, let's say, a basic shape. You create the constraints, you put like a goal, reducing weight or maybe avoiding certain resonant frequencies. And you can do a simulation where the system is able to remove the material. And also you can specify, of course, the process that can be machining, additive manufacturing, and the result will be different. So this will allow to create a lightweight version of parts that will be mounted on that drone. So this is, as you can understand, an innovation platform. If you want to do additive manufacturing, we also have simulation of the additive manufacturing process because you want to understand if the part will be distorted. And we also even have software for scheduling of manufacturing or solution for machining, solutions for quality control. So the platform is not really confined to the design office, but as solutions for every portion of the company. So really, it's an holistic platform that provides specific solutions for any kind of industry. Or here, these are solutions from our Delmia brand, where you can even plan the manufacturing operations. So what are the sequences of operations to build this plane? What are the instructions? What are the resources that I will need? Or you can study the ergonomics. How should I plan my manufacturing to have the best ergonomics for my operators? And you can create also dashboards that can monitor the production and see if you have bottlenecks during the different phases. So University of Kiev doesn't have these solutions, but it was just to show you that the platform allows to create a virtual twin of your manufacturing process of your product and can really study all the aspects that are involved in the development of your product. This is what they are seeing now is the scheduling operations for what concerns manufacturing. We have software to manage the logistics. For example, this is another solution for simulating the robot operation. Again, maintenance instructions, software to create maintenance instructions to instruct people how to replace certain parts of a plane. So I think now you understand that it's a very vast solution. And the beauty of it is that all these applications are talking the same language. So once you save your data, any application can read your 3D model and then from there create a simulation, machining operation, manufacturing instructions. Anything starts from your 3D model because we have what we call a unified data model. So all the applications speak the same language. There is no need to import and export files. And it's also a collaborative platform because you can decide what data will be available to the different stakeholders in the company. So next is explaining what the University of Kiev has. University of Kiev has a product called Solidworks X Design. It's a product to model in 3D from a browser. How does it work from a licensing point of view? I will try to explain. When you you need to be invited by the administrator of the platform, that in this case I think is Oleg, and he invites the student, and he will need to provide 3 licenses. The first one is called 3D Swimmer. It is needed to access the platform. It's like it gives you an apartment and it gives you the keys to open the door to that apartment. So this is needed just to enter the platform. Then there is a second license called Collaborative Industry Innovator. We can say that this is like the vault. So it's like a space where you can save your data and also do life cycle management. So like revision management, change management, and many things. So if you want to save some SolidWorks data to the platform, you need to have Collaborative Industry Innovator. On top of it, there is SolidWorks X Design, which is the role that allows to do modeling on the platform. And there are actually different applications. One is called X Design that allows to do parametric design. So it's very similar to SolidWorks. It creates parts and assemblies, but it does it from a browser. There is another application called X Drawing that allows to create drawings from a browser, but it's a special application because when you create a drawing, it will automatically create also the MBD. So it creates annotations on the 3D model organized in views that can be used if your final customer is a company that doesn't want a 2D drawing but wants an annotated 3D model. And there are other applications for designing sheet metal structures, molds, and also one application for doing rendering. So it's a complete solution to do more or less what you do in SolidWorks, but from a browser. So what are the special features of this X-Design? First, because it's cloud, so you don't need to install anything, you access it immediately. It's a secure because we protect your intellectual properties. The data management is embedded. You can use it from tablets or any device, and it's very easy to administer it from a licensing point of view because there is a console where you can see the students, you can see the licenses that they have, you can remove licenses, you can invite new students. Let's see it in action. So this is Solidworks X Design. So what you're seeing now is the main application called X Design. And here you can see X shape because you also have free-form modeling. We call it subdivisional modeling. So there is an application that allows to start from a primitive shape and then to model in free form. You also have parametric modeling with X Design. So basically, same way of working of SolidWorks. You create parametric features when you from a sketch. You also have capabilities for 3D printing and also data management. So you can create revisions. And this is the collaboration. So if there is an issue, you can communicate with others. Again, this is the free form. So if I want to create an handle, it's very quick because I simply need to push and pull. So when you have a complex shape, it's more suited than the parametric modeling. This is the sheet metal application that allows to create a sheet metal and also create a flattened view of your sheet metal. Of course, you can create assemblies, and here you can see some AI to automatically replicate components. And as I said, you can work from a touch screen without any problems. This is the application for creating structures. It's called X-Frame. So there is a library of profiles, gussets to model. And this is the rendering application called Xstudio that allows to create a realistic rendering. And this is the app for creating drawings called Xdrawing. Of course, when you save your data to a platform, anybody can then display your model in 3D if you allow it. So you don't need to send emails if you want to show your work to your professor or to a colleague. As I was saying, this portfolio includes a lot of AI capabilities and is designed to be very easy and very fast to access. Indeed, we recently changed the user interface. Now it looks like a web page where you have a homepage where you can find tutorials. So let's say you want to learn X design. When you open the software, the first thing you see is a list of videos to learn the software. And you have a different number of lessons to learn how to use X design or X shape. So we have created this web page because it's easier for a student. If you want, you can open sample models, or you can also explore one of our blogs where people put their models and you can discuss or ask for help. And then we have the create page where you can start modeling with the X design directly from your browser. As I said, you can model parts and assemblies. And on the right is very convenient because you have some modeling tips or some inline tutorials. As I was saying, these solutions are different. So this is the solution for creating drawings. So once you've modeled your part or assembly with X design, you can start creating your 2D views and adding your dimensions, your tolerances, your section views, and so on. The beauty of this solution is that it's a dual solution. So it's both drawings and MBD in the same software. So I created a view on the drawing and now I have it in MBD so that I can now work also with people that want MBD. So you can, and it's also true the opposite. So I could create something in MBD, and then add it to a drawing. So you can decide which way you want to work. This software is the software that is evolving most because we are upgrading every 2 months, every upgrade of a platform. So you can, as you see, create your section views, or you can create your detail views. So it's suited for working in an academic environment where you need to create drawings according to standards, and we follow the ISO, the DIN, and the ANSI standard for creating drawings. This is, for example, a detail view. As you see, the label of a detail view is not available in this current release. Is available. So if you don't find something, be sure that in probably 2 months you will find the capability that was missing. Again, here we are showing that you create the drawing and the MBD is created automatically for the suppliers of customers that want to work with MBD. Also, these applications are integrated with virtual reality and extended reality. So if you have a virtual reality headset, you can immerse yourself in the design. So if you have an HTC Vive, you're able to walk in your design and teleport and explore your design. So we are trying to integrate this technology because we know that many students and universities are exploring this kind of technology. But also we have augmented reality. So maybe I will show you also the other example. So in this other example, we are exploring a different kind of model. Yeah, this is you can see also the augmented reality. So you can rotate and explore your model directly in the context where it's being used. So I am in my room, my model will appear, and I will be able to manipulate the model, hide components, scale them, rotate them. It's something really, really interesting. I will show you something about AI. So let's say you have an assembly and you have to place like 50 screws. So what I can do with AI, I can ask to replicate the component with mates. This is not exactly like a linear pattern because, the holes are in, let's say, almost chaotic pattern, but also there are holes in other planes. So you can help AI by selecting other holes. AI will learn and propose you other places where to replicate the screw. So as you can see, the more you help, the more positions are recognized. So those numbers are the number of screws that will be created by the artificial intelligence. This is only one example of a different AI technology that we have in XDesign, but once you have defined the positions, in just one click, you will see that 50 screws will be created with all their mates. And we have other examples of artificial intelligence applications. Here is another example that is applied to the sketch environment. So I need to finish one sketch, so I will create one circle, and then I can create some constraints. I can then decide to ask AI to replicate those circles in similar positions. And as you see, basically in one click, I have my whole sketch defined also with the dimensions. And AI is applied in different contexts. For example, one recent project we implemented with AI is what is called the image to sketch. So I can add an image to my 3D model in XDesign, and then I can ask the artificial intelligence to recognize the image and transform it to parametric entities. So, for example, if I want to extrude that text, I can now do it. And it's really very precise because you can get very good results in recognizing images and adding them. To make a more practical example, if I need to have a Bosch profile for structures, I can take the picture of a Bosch profile and it will automatically recognize it and transform it to parametric entities. And also, you can do sketch mechanism recognition. So this is an image of a mechanism. The AI can understand the mechanism from the picture and automatically create the constraints. So it can understand that there are some hinges and this is how the mechanism should work. And then from here, you can create a 3D model. Another example of AI is the command prediction. So instead of looking at the toolbar, you have a single command predictor. And as you go on and create your model, the command predictor will adapt and show the different commands. So if I create a sketch, it understands that the next command I need is the extrude. If I create an axis, it understands that the next command I need is mirror. So it's a very intelligent way of learning from the user and anticipating the user. Also, you can, of course, import other models from different CAD formats. So, for example, if you have a step file, and let's say I need to create a drawing or an MBD of this step file. So there is no information about the hole depth or the type of hole. We have an interesting artificial intelligence technology that allows to create hole callouts. So the hole callouts command will recognize from the shape what kind of hole is present. So for example, here you can see that it created a counterboard hole dimension and it also understood there are 4 of them. So these are a few of artificial intelligence applications, but there are more and more coming and more that I didn't have time to show you. Also, in my opinion, the most beautiful thing about this platform is the collaboration. You can really work on the same project, on the same design together without having conflict. Indeed, when I collaborated with a university called Politecnico of Torino, they created a 1,000 part BMW engine, all working together thanks to the capabilities of a platform that allow you to keep your data secure and segregate the information. Let's see a practical example. One user on the left is working on a component. What he can do, he can lock the component. So it means that only this person can modify the component. The other person that maybe is working on parts, he will see a notification saying, hey, the other user now is working on that component. You cannot really modify it, but that's correct because there shouldn't be any conflict when working on the components. Plus, let's say this user now is modifying the part, so increasing the number of instances of that part. When he's done and when he saves, the person working on the assembly will see on notification saying, hey, the part has changed. You should update it if you want to see the latest version of the part on your assembly. And then you can click on the button and see the updated design of that part. So it's really created to collaborate on the same design. Indeed, I suggest you as an experience to try to work on a project all together as students and see how this helps the collaboration. Also, there are PLM capabilities like task management. So instead of calling my colleague or another student, I can create a task for him or her saying, please model this component called skid plate. So I can create the task, assign it to somebody, create a description, and then this person will receive a notification. I can put a due date. And then if I want, I can also attach the assembly, saying you have to work in this assembly because the skid plate has to be placed in this assembly. So it's easier to understand the context of the work. So then this person will receive a notification and will be able to access the task and have a look. Also, as you see, there is a chat capability inside the platform. You can also do chatting like WhatsApp inside the platform. You can do audio calls, you can do video calls, you can do screen sharing. So it's an environment designed to work here and without other tools. You can even create Word documents, PowerPoints, Excel files directly here without needing to open Excel, Word, or PowerPoint. So you can have a discussion thanks to this conversation, like, okay, please explain the material, and then you can proceed and continue working. So as you see, it's a more social way of collaborating between students. There is also actually a mobile app called 3D Swim for seeing the notifications also on the phone. Also, the beautiful thing is that if you want to show your work to your professor or somebody else, maybe an external person, you can create an external sharing link, and then anybody that has this link is able to display your work. So they will receive an email with this link, and they will be able to explode the model, take measurements, hide components, create section views. So this is much better than sending an email or a screenshot, because usually people send set files by email, but this is not ideal because you are sending out your intellectual property. Here you can send it externally, and also the external user can create screenshots and markup and comment so that you have some feedback, and you can start a discussion. And instead of having a discussion through email where you easily lose information, you do it directly in a social way where everything is tied to your model. Actually, as I was telling you, this is just the surface. This is what the University of Kiev has, but there are other capabilities, other roles that you can have. For example, application to do rigid body simulation or create presentations or doing algorithmic generative design. Maybe some of you know Rhino Grasshopper. We have an application called 3D pattern X generative design that is similar to Rhino Grasshopper. For example, this one I'm showing you is the application to create presentations and interactive instructions directly from a platform. So you open your model created by Xdesign, and you are able to create exploded views, and you can create slides to tell a story about your model. Then you can create your explode lines. You can add balloons, and you can create an interactive bill of materials to explain how your model works. And you can publish this as a technical illustration, so as an SVG file, so a vector graphics file. Or if you want, you can create an animation. So each of those slides can become part of the animation, and the software will transition between the slides, and you are able to publish it as a video or in a community, because we also have communities which are a private social network where you can collaborate together on a project. And from here, you can display your presentation that you created thanks to this software. So this is also an interesting application for student projects. So it will simply transition between the different slides. Also, we are developing an application that will be released probably next year. It's called X Mechatronics. It's an application designed for creating mechatronic devices. So it includes the mechanical design part, but also the electronics, the PCB, and the wiring part. You can do it all on the same environment. Actually, this is a project from one of our Indian colleagues. They created with this application a machine to automatically solve the Rubik's Cube. So keep an eye on next year because we will release this interesting application. Then the University of Kiev has another possibility. I will explain to you. My personal preference would be using Xdesign because it's easier to use. But if you want, you also have a role that allows you to connect SolidWorks to the 3D Experience platform. So what does this mean? It means that you simply need to have assigned that license, and then you will get an add-in on the right part of SolidWorks that allows you to manage SolidWorks data on the cloud. So all you need is an internet connection, and you'll be able to save your SolidWorks data to the cloud, to our 3D Experience platform. And this means that if you want to learn how to do data management, now you can do it without needing to have a server. Because, today I'll make an example. If you want to share something externally, with the current process, you have to do something very complicated. You have to upload it to WeTransfer. The person that received the file has to download some CAD viewer. And then the problem, in my opinion, is that they have your intellectual property and not always they will delete it. Also, the security could be a concern. Maybe your company doesn't want you to use Dropbox or whatever system to share externally. And you need also to know what CAD viewer can open SolidWorks files. Thanks to this role, we are solving this problem because you can share externally your models and you can view them from any browser. And we grant the usual security standard that I explained before. So how does it work? If you have that license, you'll be able to have a new toolbar called Lifecycle and Collaboration with a button called Share. Thanks to this button, you will have the ability to externally share your model. You can choose different formats. My advice is to choose 3D XML because it's the most secure format, because 3D XML has only graphic information. There is no way to reverse engineer it. So it's not like a step. There is no mathematics inside of it. So you can decide to use this 3D XML, and then you have a form. And in this form, you can decide to enable the feedback from the other user. So, for example, you want to ask if this design is okay. The other person that doesn't have SolidWorks can tell you, can give you some feedback. Then you put the email of the person. It means that only the person with that email can access the link to access your SolidWorks file on the cloud. Then you can add a message because there will be an email. For example, I can ask, please give me some suggestions because I need to, I want a quote for this 3D model. I want you to manufacture the 3D model. So it will be shared externally outside of a platform on the cloud. So the person will receive, let's say your supplier will receive an email like this with the small message, and then he or she will need to click the link. And with the link, they will be asked to access the platform, but meaning that they don't need a license. They need what we call a 3D Experience ID, which is like a Google account. It's completely free. So it takes 5 minutes. There are few information to put. So your supplier, once they have the 3D Experience ID without any license, they will be able to open the link to display your model. So without installing software like eDrawings or GrabCAD or other stuff, they will be able to display the model. And this is a very professional viewer because you can change the background, you can change the display, so edges, wireframe, and so on. And there are capabilities that usually you will find in viewers. For example, you might want to create a section view. You can create section views. So, for example, you can create a simple section view, but you can create complex section view. For example, a section view through two axes, which is something that not all viewers have. So it's actually a very powerful viewer that is available for the person that will receive your file. Another use case, I want to measure something. I can measure distances. So there are filters to identify faces, edges, or circles. For example, I can measure this linear distance, but I can do also something much more complicated. For example, I want to measure the distance between the holes, but not exactly the center of the holes. I want to measure the minimum distance between the holes. So I have an option where I can say I want to have the minimum distance. So this is also a very advanced feature that you don't find in all viewers. Also, let's say you're a supplier, you want to provide some feedback. Today, you are sending a screenshot, and also then there is a big exchange of emails, and you know that emails can get lost. And also, if you start a discussion from email, you go back and forth, and sooner or later you lose the information in those emails. Actually, thanks to the connection of Solidworks to the platform, we give the capability to mark up. And this is a great degree of collaboration because the communication happens directly on the Solidworks model, and you can keep all the traceability inside your model. So let's see a practical example. I have the ability to suggest that I want a pocket there, so I can draw, and then I can also add a note on my model, and I can do it as many times as I want. For example, I can say, okay, I want a chamfer in that position, and then I can capture as a comment the markup. So for example, I can ask, can you please provide a drawing with these chamfers? And then in SolidWorks, you receive a notification about the comment, and you can display the comment directly inside of SolidWorks without leaving your environment. And you can browse through the different markups. For example, here it's very useful because I can see the shape of a pocket. And for me, then it's very easy to model the pocket inside of SolidWorks. And not only you can share parts, but you can share also drawings. And here you can decide the format. So I can share as a DWG, PDF, DXF. I decide what kind of sharing I want to do. Most importantly is the security, because let's say that the engineer has modified the SolidWorks file. In the traditional process, you will need to create a copy of the file. Today, with the SolidWorks connected to the cloud, let's say the supplier is seeing version 1 in this moment, if I modify the SolidWorks file, all I need to do is to share it again. The system will remove version 1 and will automatically display version 2. So your suppliers can automatically see the latest and greatest version of your designs without any problem, without needing to manually update something or download a file from an email. So when I share again with the Pocket, the system will ask me, do you want to update the existing design? And the supplier then will see the latest and greatest design. Of course, this is also for the drawing. So if I have created a drawing, I can display it from the platform. Also, I was talking about security. So let's say that I don't want to anymore the supplier to access the model I shared. I can revoke access at any time. So this person will not anymore be able to display the model. So how does this work? Simply from SolidWorks, I will need to go to the model that I shared externally, and I can remove the email of a person, or I can completely disable the sharing. By the way, by default, the sharing link will expire after 30 days. So if you forget after 30 days, your suppliers won't be able to see the data anymore. Also, another problem is that sharing a big assembly like this of 1 GB today, it's complex because you have to send maybe a step file, and maybe the people that want to display it don't have a powerful computer. We are solving also this problem because when you're sharing to the cloud, we're using this format called 3D XML that not only protects your intellectual property, but it's also lightweight. So let's say if it was 1 GB, when uploaded to the cloud, maybe it's a few kilobytes. So the person will receive this whole assembly and will be able also to display it even from mobile devices. So even from a phone, you're able to rotate this 1,000 part assembly, and you can do markups if you want. You can do explode. You can do whatever I've shown before from desktop computer. So this is a very powerful way of collaborating. As you see, I can explode it from my touch screen. It's a very nice capabilities that the platform is providing for you. So the advantage is that it's very easy to share and you can showcase your design wherever you are because it's on the cloud. So I think I showed you the advantages. So this is the first level of capability, but then we can go deeper, but I will show something very brief because I don't want to go over time. We have another level that we call store and revise. So let's say that your university wants to learn data management. What you can do, you can save your SolidWorks assembly, drawing, whatever to the cloud, and you can even create revisions of your assemblies. You save it, and then the same can be done for the drawings. The beauty of this is that there is an automatic revision table that takes the information from your revisions and shows who created the revision, when, why, because you can put a comment. Everything is automated. And you can also do life cycle management. So it means that I want to release a design. What does it mean, release a design? It means that this design is finished. It should be read-only. Nobody should be able to change it. And unless, if you want to change it, you need to create a new revision. So it's the first concepts of data management that you can teach, because in order to play with this, you don't need to install any server or any other software. You just need the add-in inside of SolidWorks. Of course, when you save the data, you can see the folders on the cloud. You can search your data and you can insert it in your assemblies, just like you're used. This is an interesting capability that you saw before. It's called lock and unlock. So when you see a green key, it means the assembly is locked by you. Nobody else can modify your assembly. When you see a red lock, it means that the other user, in this case, then designer, is modifying this part and you cannot modify it. But then simply you can send a message and ask, can you please unlock this because I want to do a modification. So it's another level of collaboration with your peers. And the biggest value is that once your data is on the cloud, the people in your university, so for example, the professor wants to revise some homework, he can open the SolidWorks assembly or the drawing and display the drawing. Also, there is a nice compare capability. You can compare what changed between revision 1 and revision 2 of this drawing. So red is the old design, green is the new design. So very, very interesting capability. You can also display the structure of your assembly from a browser. So I can display my assembly without having SolidWorks, and I can show it to others. And then there are these two applications that side by side show the assembly structure and then the parts. The parts highlight when you click on them on the tree. And then you can see information like the properties. So what is the material? What is the item number? Who created it? When? Then we have one last level of capability. We call it manage and control, because this is really full PLM. Probably you will not get to that level, but I want to show it to you because it's very interesting. So in this case, you want to create a structured process. For example, there is one person that has to approve your project. So I want to see all the designs that are in frozen state. Frozen means that they are temporarily blocked from being modified until the person that is responsible for the design gives me their approval. And then when he approves, it becomes released, so cannot be modified anymore. So I can identify with filters what are the frozen designs. And so as a responsible of the project, I can display this design to understand what parts are there. And I can put them in the approval process. So you can create, for example, parallel approval process. So in the first step, a person with the initials EE has to approve. And then in the first step, I need the approval both from AA and from SS. If they approve, then there is the last stage. Maybe it can be somebody in manufacturing. If he approves, then the model will become automatically released. So every person can display the task and put a comment and approve. And the beauty of this is that there is full traceability of people that approved. So who approved, why, when. Again, it's traceability of what is happening in your design. And as I told you before, once the approval comes, the model is automatically transitioned to released state. So nobody can touch it or modify it unless it transitions to from revision A to revision B, because you want to have some history of changes. And then there is the concept of issues. So today, if you want to explain that your assembly has issues, you create an Excel file. Here, I can create these markers on the different components to represent an issue. So I want to say there is an issue in that component, and I can describe the issue, and then like a manager of a design can have a look at all of these issues. And then they can work on the issues. For example, what is the action that should be taken? What is the recommended solution to solve the issue? And then you can see that the issue is connected to the parts and assemblies, because you can assign the solution of this issue to somebody, for example, to the designer that has to make a modification. And again, you can communicate using this chat directly in the issue. So the designer will have a task, will modify the design, will then put the task as complete, and will be able, and this has traceability. So you can even create reports and understand why there are how the issue was solved, and this is useful for continuous improvement. So if a similar issue comes in the future, you will know how to solve it immediately. As I said in the beginning, once your Solidworks data or your X-Design data is saved to a platform, you can leverage all the technology from Dassault systems to do other things. For example, governance. So I showed you a few capabilities, but there is an application you have to create a Gantt chart of your project to understand who is working on what is the status of a project. You can create toolpaths for your machines. You can create presentations for marketing. You can create machining. And you can do also very advanced simulation, very complicated simulations, because we have the Simulia technology that is powered by Abacus and other solvers. It's one of the most powerful available in the market. You can even do a simulation of your layout. So you can put a point cloud scan of your plant, and you can put your machines and simulate how they work in your plant. Really, there are solutions for any kind of need on the platform. So you have let's say the entry point, but there are many of them. Then I don't know if this is the same. I think this is the same video that we saw at the beginning. Okay, I think I finished. I don't know if Alex wanted to add something, because actually he's working for our Simulia brand, which is very vast. Maybe he wants to show something.
Alessandro, thank you so much for this very impressive presentation. I'm sure you have convinced many users to move away from the desktop solution to the platform. Let me share my screen and show very briefly what it is all about, and then we will very, very briefly, just as an introduction. See if I can. Okay, I think I am in the right one. So I wanted to show you first different ways of communicating with the platform. And as Alessandro already mentioned, in the first reason why you would be using the platform is because if you do the simulations, you need to load the model somehow and do it, set up the analysis in one of the Simuli applications. And this example was written for Opera. And then somehow you need to make some changes in Solidworks and then repeat the whole exercise again. And unfortunately, if you're not using the platform, very often what you would need to do is to do it again and again from scratch. And this is inconvenient. Scripting is used, for example, in this particular case, for talking between CST Studio, which is electromagnetic software, to Abacus. And in this case, you can see that Abacus is called by some Python scripting or VBA scripts. This is another potential technology. This one is when you use so-called connectors. I will try to play this because it's a very short video, and you can see it's a SolidWorks plus a CST. So you can connect the two applications using the connector, and then you can change geometry either in CST or in SolidWorks, and the parameters will change in both, and the geometry will be updated. In SolidWorks, these parameters are called global parameters, but in CST, you will see them as because you're passing only a group of parameters which are global parameters. And as you can see now, the model is updated simply by changing parameters in CST, and the SolidWorks is updated as well. This is getting convenient for that sort of simulation. Then another one is that you need to, apart from exporting and importing and make changes to the code, then another story is if you need to use several simulation tools. For example, I will show you work I have done recently on degaussing. And degaussing, if you don't know, this is a method of removing ship signature. So basically, it's an effect related to deformation of the magnetic field around the ship because the ship is made of permeable materials. And when you design a ship for the Navy, you want to eliminate the signature, and you use a set of cores, as you can see. And to cut the story short, you use this sort of workflow where you have model build and cut, then you have finite element analysis, and you need post-processing results, and you need to find the optimal optimization of currents in the cores and position of the cores. So potentially you need to change geometry of your model in CAD, then you need to update electromagnetic model correspondingly and set up currents to different values, and God knows how many times you want to do it because you don't know in advance actually how to set everything up unless you have 10 years of experience behind you. In this particular case, we use optimization process composer, which allows you, which is one of the applications of the platform, and the process composer allows you to carry on the analysis and pull the data from CATIA, from CST Studio Suite for electromagnetic applications, and then later on use results analytics, and you can see that how quickly everything is going almost on a straight line to optimize solution. So that's and it you pull other tools from the platform, like in this case results analytics, and you can investigate how different parameters, what effect they have. For example, you have different correlations between parameters, and you can see that parameter on the left has hardly any impact on the results, whereas others change dramatically if you change currents in one of the cores. And then you can see what could be achieved. The red line is what I managed to achieve playing manually and trying to improve it, and starting from the green line, which is the initial signature. And the blue one is what optimization process composer allowed me to achieve. So in this case, the ship wouldn't be visible to mines, and because the magnetic field will become almost uniform anyway around the ship. Then there is another more exciting thing with fluid dynamics. I want to stop on this slide because this could be a nice homework for you, for most of you. This actually is an example from the user assistance website. If you go there and follow one of the links, you effectively will get to the area where you can download the model and get all the instructions how to set it up and run the simulation and get final results. So you can see this is a model of a drone, and using essentially the same sort of things, like you define the model, then set up finite element analysis and calculate dependencies on air, on pressure on the wings. I think here in this particular video, I will play it to the end. The video shows how you set up structural analysis, how you set up, structural analysis part and then fluid analysis part. And then finally you get a couple of results where, if I let it play further, you can see that we plot some local surface pressure, and then we plot local velocities and streamlines. And then you can do structural analysis, proper structural analysis on this. Basically, the story here is you design a drone, and what you want to achieve is you want to find what is the optimum number, for example, of optimum values of different parameters, like number of ribs or thickness of the shells, because what you want to achieve that the buckling, buckling is a deformation of the surface of the wings, is within a 3 millimeter range, and also deflection of the ends of the tails is less than 5 millimeters. And all this story is showing you how to set up the model, how to constrain it to get where you want by playing with a couple of parameters. So this is also quite an interesting example, and I would, you can see all the constraints, pressure loads, meshing. Meshing is usually it's a difficult subject, but here it's on the platform when you do meshing, it's very easy. And here you can see that von Mises stress is calculated, then deflection is calculated as well, scaling is changed. So, and you do several iterations and now calculate displacements and try to minimize this value below 9 millimeters, which is currently because the requirement is 5. So you're just making changes to your geometry, and you do it again and again and again. And you can use, because it's a platform, you can use the same model of the airplane, which you already have, and do fluid flow analysis, and you can do structural analysis as well. So within one single environment, you can get quite a number of results, and you just select what results you want, for example, in the structural analysis, and you can select on which part you want. So there is many, many options and flexibility. So you can see that finally, after changing the parameters, the geometry, the displacements were reduced to well below what was expected. So this is just a small introduction to what we want to show you in a couple of months' time. I want to thank you, all of you, for your attention. Thank you all of you so much for joining us today.